now that we understand a little bit of moments and application of moments, let me tell you an important situation where there is presence of a number of parallel forces, like parallel forces F1, F2, F3, F4, Fn minus 1, Fn. N forces, they are parallel to each other in the same direction, like parallel forces, right? And in general, they are acting at different points. They are acting at different points. And I want to replace these forces by one single force, call it capital R. I want to replace these forces by one single force, call it capital R. 1. What should be the magnitude of this force? And where should this force act? What should be the magnitude of this force? And where should this force R act? These are the two important pertinent questions to be delivered across to you. Now, one thing, in as far as the magnitude of this resultant R is concerned, that will simply be the resultant obtained from these parallel forces F1 plus F2 plus F3 plus F4, etc. is going to be simply the sum of the magnitudes of F1, F2, F3 and Fn, right? But the point is, where should this force be acting? What should be the point of application of these forces? Given that F1 acts at a distance x1, let's say from the y-axis, my choice of y-axis is parallel to these forces. It's not like, you know, the y-axis came first and then these forces. Let's say the forces were there and I chose my y-axis parallel to these forces. So F1 acts at a distance x1 from the y-axis, F2 acts at a distance x2 from the y-axis, F3 acts at a distance x3 from the y-axis, and Fn acts at a distance xn from the y-axis, right? So where should R, which is F1 plus F2 plus F3 plus Fn, act? Suppose R acts at a distance x bar from the y-axis. R acts at a distance x bar from the y-axis. So this is the translational equivalent. This is the translational equivalent. But then the point of application will be the rotational equivalent, right? Essentially, if R is indeed and truly the equivalent of all these forces, then the moment of these forces about O must be the same as the moment of R about O. That will be the rotational equivalent, right? So what's the moment of R about O? R into x bar. X bar is my objective here. So R into x bar. R into x bar, right? And that must be equal to, so this is the moment of R about the y-axis, about O, R into x bar, R into x bar. That must be F1 x1 plus F2 x2 plus Fn xn. That such must be the rotational equivalent. So R must act at a point x bar units away from the y-axis such that the moment of R about O must be the sum of the moments of F1, F2, F3, Fn about O, which means x bar must be, this is like summation fi xi. This is like summation fi xi, I equal to 1 to n maybe, divided by R. What is R? R is F1 plus F2, that means summation fi. F1 plus F2 plus Fn, I equal to 1 to n, right? That is the equivalent application of the force, right? So R, replacing all these forces, R must have a magnitude F1 plus F2 plus F3 plus Fn, and where should R act? R must act at a point that its moment about O must be the sum of the moments of F1, F2, F3, Fn about O, which is this, right? And that gives me x bar, the point of application of R, so that the equivalent is established. How about it? So, you know, where is it that we encounter like parallel forces, right? Why did I give it special treatment? Why on earth did I give it special status, right? I'll tell you why. I'll tell you why I gave these like parallel forces special status. Check this out. Now I'm going to talk of a body composed of a number of particles. I'm going to talk of a body composed of a number of particles. So this is a body, and it's composed of a number of particles, right? And their weights are W1, say W2, W3, W4, Wn, right? 5, etc. This is W1, W2, Wi are the weights of the constituent particles of this body. Particles, right? Now, suppose this is my y-axis, this is my y-axis, this is my y-axis, and I want to replace these particles. Say this is particle A1, this is particle A2, this is particle A3, this is particle An. I want to replace these particles by one single particle. By one single particle whose weight would be the sum of the weights, Wi. That means that's going to be W1 plus W2 plus Wn. I want to replace these by one single particle whose weight is the sum of the weights, W1 plus W2 plus W3 plus Wn. Surely, but the point is, W1 is the particle A1, W2 is the particle A2, W3 is the particle A3, and I want one single particle whose weight is W, which is W1 plus W2 plus W3 plus Wn. Now, where should that particle be? That particle represented by the weight W is the particle A. And where should A be? And where should A be? Where should A be? Now, this follows from these are all like parallel forces. Do you see that they are all like parallel forces? These are all like parallel forces. And say this is my y-axis, this is my y-axis. And say the distance of the y-axis from A1 is x1, distance of the y-axis from A2 is x2. That means, you know, these are the x coordinates of A1, A2, A3, An. So, xn. And x bar is the x coordinate of A. This is my equivalent particle. This will replace this collection of particles by one single particle whose weight is the sum of the weights of these constituent particles. And this particle then is called the center of gravity of the system. This point A is referred to as the center of gravity of the system. Center of gravity of the system, of the collection of particles. And let me tell you then, they also constitute like parallel forces. They constitute like parallel forces. A1 has x coordinate x1, y coordinate y1, A2 has x coordinate x2, y coordinate y2, A3 has x3, y3, An has xn, yn, and A, whose coordinates we want to find are say x bar, y bar. This single particle will replace this collection. This point particle will replace that collection. Will have a total weight equal to the sum of the weights of these particles, constituent particles. And let me tell you then that the x coordinate of A, which is the center of gravity of the system, which is the center of gravity of this system of particles, is given by x bar equal to, taking moments like what I did a little while ago, and you might want to explore why this happens, W2x2 plus Wnxn by W1 plus W2 plus Wn. This is the x coordinate of the center of gravity of the system. The y coordinate of the center of gravity of the system then. So this is like summation Wixi divided by summation Wi. Summation Wixi divided by summation Wi. The y coordinate of the center of gravity will be given by W1 y1 plus weighted average of these y's, y2 plus sum of the weights, Wn. That's how you get the coordinates of the center of gravity of the system. Of center of gravity of the collection. Center of gravity, or you can call it G, capital G. Capital G. Now, one thing that I need to mention, we'll come into detailed discussion on all of that at some other point of time, but the fact that you must take notice of is that if this body is much smaller compared to the size of the Earth, then G will be, acceleration due to gravity would be uniform over this region. G would be uniform over this region. And the weights could be replaced by masses. The G will get cancelled from the numerator and denominator. W1 can be replaced by the corresponding mass m1, W2 by the mass m2, Wn by the mass mn. So this is x coordinate of this will become m1x1 plus m2x2 plus mnxn by mass m1, mass m2, mass mn. Same for y, m1y1 plus m2y2 plus mnyn by m1 plus m2 plus mn. And that will give me what is called the center of mass of the system. That will give me the G then, which is the center of gravity, becomes synonymous with the center of mass. Becomes synonymous with the center of mass. So if it's a body whose size is small compared to the size of the Earth, and over which we can imagine G to be constant, then the center of gravity and the center of mass are identical points. So the center of gravity will become the same as center of mass if G is uniform over this region. Acceleration due to gravity being uniform over this region. So essentially, what is center of gravity? I want to replace this collection of particles by one single particle, whose weight is the total weight of this body, right? And it acts at a point whose x and y coordinates are these, where x1, y1, x2, y2, x and yn are the coordinates of the constituents of this rigid body. Does it make sense to you? So this then gives you a brief outing on what is exactly meant by the center of gravity of a collection of particles. But then I have a lot more to add. In a while, I'll be back with you. Thank you so much.